inventory manager for France and Iberia in Stratasys. So the three business areas where we are focusing on are really linked to the three level of advancement from concept to the manufacturing. So when you think about a product that has been to be designed and produced and manufactured, you have first to start with a concept design, then go through prototyping where you test some specific functionalities, and then you go to the manufacturing. So these three pillars are really where we are focusing on to develop our solutions. So when you look at the concept development, you need to have access to some kind of solution which is going to give you very quickly access to a 3D printing product that you're going to share with your customers, with your internal customers, external customers to validate the design. And this area, we're really developing solutions which are more accessible with solutions like the MakerBot or even our low-end entry solutions, which is delivering fast prototype, visual prototype that will help them making the decision. And this is still growing fast. The next level, which is really in the prototyping area, requires a little bit more involvement of the technology because you need to go through functional testing, prototyping, making sure that whatever you've designed is going to fit an assembly or really go through some testing, whether it can be a wind tunnel, for example, on this car that you will need to do for validating the design of the part. So here you will be looking at development of different technologies to help supplying technology which is going to be fitting their prototyping functional requirements. So we're working on our pillars of technology, FDM, polyjet technologies to provide the solution that will best suit this type of performance test. And then the third level, which is really in the manufacturing side, is really looking at how you can use the technology to manufacture short production, low quantity, high value production quantity, customized quantity, to solve problems for industrial companies which are really looking for a way to optimize their product performance. It could be performance of cost or performance of flyability of parts in aerospace, for example, or different areas like in this race car motorsport where you need to have a small number of quantity of parts but will have some specific design that you can very quickly change and put on the car for the racing. So you're looking at areas of performance, material performance. So we are developing our technology to bring even higher performance material to fit these requirements. So we are constantly developing our solutions which are not only material, it's the combination of equipment, printer, solutions, software, and material, of course, to make this combination a working solution for an industrial which is looking at very specific performance. We see still growing demand in terms of the growth of need of using this technology, 3D printing solutions in this world to fit the needs for each single designer, personal designer, or design studios which are going to work within a company or outside of a company to really develop these products that they are going to be key for those markets. So we see the growth in these areas, whether it's on the early concept design or prototyping, very solid. And it's a growth that is going to be maintained by the need of many companies to go faster to the market. So they want to have better product, faster to market. And when you go into the manufacturing process, this is quite new, even though in the manufacturing process there are two different areas. One is looking at, as I mentioned, the end-use parts. So when are we going to be able to manufacture parts which are going to be on cars or in planes or in trains or any product that you want to manufacture. But the other aspect, which is quite important as well, is referring to whatever you need to do for tooling, assembly. In every manufacturing line, you can optimize your production facility by using the 3D printing technology to have better capacity with your tooling, with your device, with everything that is going to optimize your workflow process internally. And with those kind of applications growing every day. And the end-use part is really an area where we see the benefit in vertical areas like the automotive or the aerospace. In the automotive, like we see in that car, this is certainly more focused on areas where we're not looking at huge quantities of parts. But if you look in the car industry, you have many areas where you could imagine using the technology for very specific application. Even you can think about customized application. If you look at the high-end range of application in the car industry, you could think about personalizing some of your item inside the body of your car and have some specific design and production that could be served by the additive manufacturing. So in this car, you can see there are areas which were used purely as prototyping to validate the concept, the design. So when you look at the airflow distribution on the side, how do you design exactly the best decision? So you can do the prototype, check it internally before putting on the car the right design, and then you go into the manufacturing. So normally there is a lot of parts which are done with let's say conventional way of manufacturing. And this car still has got a lot of conventional manufacturing process, including carbon fiber. But there are parts which are always critical that you can change quickly if you have a crash, or if you have some very specific part like the one which is the camera holder on the top of the car has been done with additive manufacturing. There is no specific constraint in terms of mechanical constraint, and it makes the additive manufacturing process with our thermoplastic material fit perfectly the use of that technology for that part of the car. The inside dashboard of the car is also something which was completely designed and manufactured for that car using the FDM technology in that case. And when you look at areas like the side way of distributing the air, there are parts which have been designed, produced for prototype, but also that they can use for end-use part as well on this car. The ecosystem we're working on with a new setup of our organization. So we have built up our organization now in vertical business units. So people who are going to be focusing in very specific areas like aeronautics, automotive, medical. And these people are working very closely on the ecosystem to understand what kind of technology is required, what kind of printer is required, what kind of material is required, what kind of software is required. So when you think about our core technology between the PolyJet, which is an inkjet-based resin system where you can mix up to 3 different types of resin, where you need to mix color or transparency or soft and hard material, you definitely need to understand how you can optimize the workflow by working with the CAD software designers and give them the ability to integrate part of our technology in their software CAD systems to have a seamless workflow when the designer is making the concept of his part, to integrate the capacity to bring color or translate what is ever going to be sent to the service bureau or to the people who are driving the printer in their house to get a seamless connection. And then this element will be translated in a file that is going to be automatically understood by the printer. So those kind of things, we're working very closely with every single developer of those software, whether it's in the medical or in the various industry where key manufacturers are present, like whether it's Dassault system or PTC. We've been working for many years, but more and more we see that the interest of the 3D printing technology is creating as well the interest from those software editors to give access to a better workflow to bring this to mass production. Yeah.